So, hi, I'm David. I'm from South Africa, so like right down at the bottom of Africa and from Cape Town. I'm currently an SRE at Garden.io. We build development tooling. Cool. So before I get started, I just want to kind of figure out like what types of users and you are. So how many of you run CI for your company or your teams or things like that? Okay, cool. How many of you use it? So that would be you build a project and you build your Jenkins file or your GitLab file or whatever. Okay, so roughly like kind of half-half. Out of the people here that run CI, how many of you run it for, I don't know, like 15 or 20 plus developers or engineers? Okay, cool, that works. Okay, and then also, like how many of you use GitLab? Okay, how many of you use Jenkins? Cool. Travis/Circle/hosted CI versions? Okay, cool. So the most of this talk is related to GitLab, but I've done similar things with Jenkins, and you can apply similar things with Circle or any of the other developer tooling out there. So it's kind of an approach using GitLab as an example, and it's a little bit meta, so if I'm going a little bit fast, just kind of like raise your hand or slow me down or things like that, and I will try and explain it in a little bit more detail. So this is a quote that I found, which basically says, human beings are almost unique in having the ability to learn from the experience of others, but we're also remarkable in their apparent disinclination to do so, which is by Douglas Adams, the guy who wrote Hitchhiker's Guide to the Galaxy. And what this means is that humans can kind of learn from each other, and we can leverage each other and be great, but we don't. Don't know why, but we don't. So here's a typical example of this. And I was trying to find like really bad examples of CI and how we don't learn from each other. And I thought, okay, cool, I'm going to go look through our code bases and try and find something. But I went to GitLab CI. And this is the CI definition for their own hosted GitLab version. And it's almost 1,000 lines of YAML, and most of it is duplicated, and it doesn't even include releasing. So it has no release process in it whatsoever. It's basically just continuous testing and integration and some static analysis and linting and some basic stuff like that, but none of their core, like upload this artifact or release this Docker binary or any of that is included. So that's 1,000 lines of YAML that somebody has to maintain and use, and actually it's just a Rails app. That's kind of scary, right? So here is my like definition of what the CI is supposed to be. CI lets us learn from ourselves, and that's great, but why don't we learn from each other? So we work in companies, and companies generally have fairly standard tool chains across teams or organizations, but we always reinvent the wheel. We kind of copy and paste some code around, and then we improve it, and then we're building a Go app, and then people have to like do what you did and optimize some Go binaries, and some of that knowledge is kind of great and it's useful and it's experimental, but a lot of it gets lost in the project. And unless you know where to look for it, you kind of don't find it, or you have to go and do stuff like that. So how do we solve this? Like in CI, it's fairly new, and like we haven't kind of gotten to the stage where we're building abstractions in CI. That's a fairly new idea. And oddly enough, the first talk was actually I was super happy about that, because that's the first time I've seen somebody providing CI as an abstraction to the users. Like people that build the product or people that are working on a system, they know best how that system works. So for example, if you're a release engineer, you know the release process and you know how things should be released and where they should go and how they should go there. If you're a security engineer, you know what and how and what tooling you're supposed to use for your security projects. And that kind of expertise either needs to be embedded in each team, and you need a security engineer or a DevOps engineer or a node engineer or like whatever. But there are ways to share that, and this is kind of an attempt to solve that. So before we start the journey, I just want to kind of pose another question to you, and that is, riding a bike. How many of you can ride a bike? Awesome. How many of you can teach me how to ride a bike now? Okay, sure. How are you going to teach me how to ride a bike? I'm standing here. I'm fairly short.
I'll give you a bike with some extensions, with
sure.
extra wheels. And
okay. And you say go.
So you sit on top of it and slowly drive with me.
And slowly drive with me, so you're going to hold me.
Beat you away, yes.
Okay, cool. And then I fall on my ass and like
yeah,
I'll fall over.
Try again and we'll learn.
Cool. But this is one of the things that are super hard to teach, right? I don't know if you've ever tried to teach an adult to ride a bike, but it's super difficult. It's almost as hard as trying to teach an adult how to swim, which is even worse. Like, I mean, I learned how to swim when I was under 1 year old, and I look at people when they're older and they get confused or they don't know what to do, and it comes so naturally. And the reason for that is that riding a bike involves a lot of physics. It involves like motion, and you need to keep balance, and you need to do all of these things at the same time, but you can't tell somebody to do them. They have to experience them. So how do we do this? And as you said, right, except I'm going to go one step back before the training wheels. You get what I like to call the magical moment. When you're a kid and you have something like this, where you're riding in a park with your dad or your mom or something like that, and I don't know if I would even classify that as a bike, because it doesn't have pedals, it doesn't have gears, it doesn't even have a chain. It's kind of walking, but on a bike. And that was the most amazing experience for me as a kid. I loved it, because I was like, I'm riding a bike, and like daddy is on a big bike, and it was cool, and I felt like I was doing something, but there was no possible way I could fall off because I was standing, right? And then after that, you get to this, which is kind of what you said with the training wheels, where you're kind of on your own, but you have these like automated support things that keep you from falling over. And this is great too, because you don't really fall over, even though you wobble and you kind of thing. But after a while of doing this, you realize that I stop wobbling when I go faster, right? And that thought process of, if I keep doing this thing and I get positive feedback, it's going to keep working, right? And interestingly enough, from step 1 to step 2 are actually giant leaps, but they seem quite small, right? And the next step is this, where you become a professional cyclist. And the difference between this and the previous step, if you kind of like think back, what's the difference? The difference here is training and doing it all yourself, and basically hours and hours of cycling on your own, okay? But it's kind of something that you can do and self-study and experience on your own, okay? Bear with me. So, like I proposed from Carl Lewis, it's about the journey, not the outcome. And as software engineers or operations people, we kind of forget this. We spend hours and hours experiencing CI or the headaches of working with Linux or Docker, and then we subtly learn things that we can't teach people, right? We learn that you need to run an operating system in your Linux distribution, otherwise you can't debug it. Or you need to learn that like copy with a slash at the end is different to copy without a slash at the end. And all of these subtle things that we just do intrinsically, other people don't know about them, and you can't really teach them. So how do we do this? So engineering the journey, right? So we can create this, in my opinion. Like, you can create the magical moment, you can create the training reels, and you can create the professional experience. You just need to put effort into it. And how do you do that? Like, these are just random examples, but by having a decent homepage and high-level abstractions and functions and pretty pictures and just making the onboarding process to what you're doing easy, so that it's super easy to adopt it. The adoption curve should basically be the equivalent of run one command or copy and paste one file, and that should just work out the box. And simple use cases that always work. Forget about the random edge cases and the existing other things. Just make your demo work or your example so that the first time people use it, it doesn't break. Because if it breaks, they're going to hate it and they're not going to enjoy it. And the second part is the training wheels part. You need to figure out a way to allow them to do it on their own, but still kind of play around and experience things. And the last part, which is possibly the most important and the most useful part, is how do you actually be a professional engineer? Because the first two in a real world where you're getting paid to do a job, they're nice and they're needed, but they don't actually deal with the real world that is a complicated, horrible place, right? Like you've got to deal with horrible, outdated libraries or corporate policies or whatever. And the thing there is you need to be able to deal with the edge cases. You need to take this like amazing framework that just worked out the box and make it your own and customize it, okay? So, as GitLab as an example, we need to stop treating GitLab as a tool and start treating it as a product and a service. So, when you use a service and you pay for a service or a SaaS offering, you have an expectation that it works, they provide service, and it's nice, right? For tooling, we don't consider that approach because tooling is ours and we just kind of like, it's something we use and do. So we need to fundamentally change the way we behave and we deal with tooling into a service that we offer to other people. So some of you might be asking about like this amazing feature called Auto DevOps by GitLab. And it's a really amazing experience. I don't know how many of you have used Auto DevOps or have looked at the video. How many? It's probably the sexiest demo I have ever seen for a product out there. It is by far the most amazing thing. You just upload your source code, it builds it, compiles it, tests it, runs it, does everything to it, and it also releases to production, oddly enough. And that's amazing. It looks like it solves all of our problems and we're basically going to get like kicked out of our jobs, okay? Which is kind of weird because the second part is when you try and like take this thing that they've given to you and then you try and make it your own, or you want to change the workflow slightly, or things behave, it completely gets weird and you can't do it. And that's where it breaks from the professional front, in my opinion. So I tried this and it provides limited customization via environment variables and some basic stuff, but you can't provide an environment variable for every single type of configuration. It's A, horrible, and B, like it's easier to just write things yourself. It's this all or nothing approach where you get given everything or nothing and then you have to deal with it. And in my opinion, it's nowhere near production ready. It's this cool demo tool and it looks amazing, but I would never run it near production because there's just too many red flags. Okay, so going slightly into the real world, what do we do about this? How do we solve this? And what is my like proposal or attempt to do this? Okay, so we have a simple Node application. It's a little bit irrelevant what it is, but it's just an Express app, so a simple web server. It's got a Docker file, it does some stuff, and it has a Docker file. So your developers have built this amazing thing, and now they kind of want to get this into production or build CI or CD on top of this. And how do you do this? How do you like take going from source code, which developers and engineers know quite well, to this automated CI CD process that is kind of new, or your company specific ways of doing that? And you need tests, you need linting, you need to build a Docker image, you need to have the same naming convention for everything else, you need security compliance, integration tests. And how do you do that? Do you read hundreds and thousands of lines of like wiki docs that were outdated, or like thousands of lines of YAML that you need to copy and paste from somewhere and then figure out how they fit together? This sounds like something people do on a daily basis, because I know that I have seen lots of teams doing this, and I'm a victim of thousands of lines of YAML copying and pasting. So, introducing shared workflows. So, this is me talking you through a real example of something that I ran in my previous company. The source code for this is open source. It's on GitHub and the presentation below. But I'm going to talk you through the process of how and why these things work and how they get there, and then you can kind of adapt them. But I just want to bear in mind that this is not production ready. This is not something you can just copy and paste. It's an approach or a way of thinking or a way of doing things that I would recommend as an approach, not necessarily taking the code exactly, but to kind of follow the idea. So this is a shared company workflow with 8 lines of YAML, right? Just 8. And some of them are even nicely commented. And with that, you get an awesomely nice automated unit tests and linting on every commit. And you also get releasing Docker images on every commit to master. Obviously, you can adjust this or do whatever you want with it, but with 8 lines of those YAML, and you have a Node application that is just a simple Node app with a Docker file, it will work as expected, right, on GitLab. So, what do we do from this? I'm going to drill down into the node workflow, which is the thing that I designed using GitLab's includes and some basic other syntax. But using that, which is just this comment, and I don't know how clear it is to kind of see, but all that this means is abstracting away the steps that are fairly standard into somewhere shared, right? All that it is it runs npm install, npm lint, and npm test, and that's it. It's not rocket science, but the thing that it does do, which is slightly GitLab specific or optimization that people might not be aware of, is it caches the node modules so that it speeds up between runs and it runs correctly, right? So it's nothing magical or rocket science, and every developer can write their own tests or their own whatever, but this kind of works out the box and then they can just use it. And people don't even need to know how GitLab CI works, or even necessarily how the arbitrary syntax of how do I get caching working, or what TTL should I use on a caching, or what naming convention should I use for my cache keys, or anything like that, okay? This becomes a little bit more complicated because Docker is complicated, I guess, but a similar logic applies. So with Docker, you can kind of abstract away the naughty bits as well, right? You can say that when you build latest, how do you build it? You pull down the latest cache from the shared image, you build it, you run it, and then you release it. And what do you do when you tag build or on specific branches? So if you have a workflow that says testing goes to your testing cluster, staging goes to staging, or production gets deployed to production, you can kind of do that in an abstract way as well. And the concept is quite simple, but quite powerful, where you design workflow scripts, and those things happen automatically. Okay? It's still a bit better, so bear with me. It'll become a little bit clearer, but these, like includes and these YAML definitions, they come from another project called CI-Base. Okay? So I'm going to talk you through that now as well. So CI-Base is actually quite simple. It consists of a Docker file, a base Docker image that has a bunch of build scripts, so that bin directory with Docker build, Docker login, Docker push, and some workflow steps. And then it has some includes, which I went through before. Okay? So if we take one of the simple bash scripts, but they could be anything, which is Docker build, and this Docker build step does distributed caching. Okay? So it automatically pulls the latest image, and it uses that cache to build the current image, which is quite important if you're not using Go, because every other language or framework out there needs to pull Maven dependencies and everything like that. And if you build them in separate layers and you do this, you get quite fast build times, because the only thing that actually changes is the last layer of the source code. Okay? Cool. All right. So we have a simple a bash build script that we abstracted away. But the important bit here is that it automatically injects the correct Docker image registry, because it follows the GitLab project naming convention. So there's no way to mess this up. Some engineer can't call their Docker project root and then it makes things awkward or weird. There's kind of this correlation between, if you know the Docker image, you can go back to the GitLab project, because it kind of matches up based on using GitLab's internal Docker registry. Okay. So I said before that the CI base also runs in GitLab, okay? Okay, still a bit meta, bear with me, but what you can do then is you can have something which I like to call an abstraction, so test script, which is basically just like a template in YAML, and you can say use Docker, so this script runs inside Docker, and then the first line of that script basically does bash hackery to pull the name of the job, right? So if you call your job build X, then test script will be X, okay? Then what we do is we run that script, okay? Next stage. So in this example, test Docker build, it will run /bin/Docker build, which is quite simple, right? But what that means is that if you always run the Docker build step, you can do unit testing on the Docker build, okay? So you're running your workflows and you're writing test cases and integration tests for your workflows, okay? So what this does is it verifies that the Docker build from the previous step was able to build itself and had the correct name, okay? Right? maybe. Okay. But you also do the same thing with your workflows, right? So you have the workflows release themselves. Okay. So you define release flows to your scripts or like your profiles, and then if this project, CI base, can build a Docker image, it can release to the Docker registry, and it follows the naming convention, right? Then it was fully integrated and fully tested because it was able to release itself. I seem to have lost people. Is this okay?
Sorry, short question. Can you tell where you working?
I'm working at Garden.
How it's called?
It's called Garden.
Garden.
Yeah, garden.io. So, like, although...
Sorry, can you rephrase actually what you're trying to make it that?
What am I trying to do here?
Like in general.
My company or this?
No.
This is nothing.
So you explain the thing, but what the main goal in that?
The main goal here is that if you have a CI, a script or a release process or a release tool, right? That tool should be automatically tested and verified to work the way that it's expected. Because when building CI pipelines, one of the most annoying things is to make a small change and then push it and then wait for the CI process that takes 15, 20 minutes of CI interaction, right? Because you made a typo somewhere or your build process had a mistake in it somewhere down the line. What doing this does is it makes your CI process modular, and those modular bits are tested in an automated way before they get in front of the user. Okay? So what this means is that my Docker build process and build workflow was tested before it even got in the hands of any one of the developers. So it would work out the box for them. And the same goes for the node process, if that makes sense. So the idea here is that you build reusable workflows for your team or your company or your like other people. So if you've got 10 teams building Node, or you have if you have like 10 different teams building the similar like tooling, they don't need to re-engineer the wheel. They can just leverage what another team built or just like use that and reuse that and stop spending time rebuilding CI, because that's what we keep doing. We keep rebuilding the same CI workflows in our companies. Like, yes, we can reuse cool tools like Jenkins and GitLab and all of that, but in essence, the workflows of the company are the things that are complicated to get right. Okay, so what this gives you as well is actually quite simple, but if you make a change to your Docker build script or you make any change in the future, because what is the point of CI? The point of CI is to verify that you didn't make any breaking changes in the future, right? And if we start treating CI as a product and a service that we're providing to other people, there are going to have to be updates or fixes or things like that. And you want to know when you make breaking changes or things that actually affect the downstream users of those changes so you can version them. So this is an example of changing, it's a change set, but changing CI commit hash to CI broken, right? And what happens then is your CI job tries to run itself and it fails, right? So you get instant feedback on whether this would work for other people. And as I said before, this is a really simple example of a workflow or a specific process, but the idea is quite powerful. So if you have 20 teams of engineers building 20 different projects, right, and you need to update a version or a workflow change, right, and you want to roll that out, currently the process is go to 20 different people and ask them to do it or make 20 different tickets, and that's a pain in the ass. It's super complicated. Whereas if you do it this way and there's no actual breaking changes, you can implement it silently without people noticing or people actually being like upset about it. Because A, it doesn't break anything, and B, it just kind of works because you verified it as opposed to doing things in the background that weren't verified. Okay, so this is kind of inception and using GitLab CI to build GitLab CI tooling, and it's automated testing for automated testing, and it's a little confusing, but what does that give you in the end? It gives you simple, easy to like use modules that are reusable across your projects or teams. So I'm not proposing this is the best way to release a Node application at all. This is just an example of how to do it. But what this means is that your Node applications, you're moving the logic of your release process out of each individual apps into a shared place that you control and you can run and you can update and you can improve. And you want to add security scanning, you just add a module and just decide to include it or decide not to include it. It's kind of this optional, like, opt-in syntax. But the same goes for, you can also take what you have here and those shared Docker images, and you don't need to use the included workflows. You can just use those pre-built images that were built and released out there that contain the release scripts in them and just call them directly in your GitLab CI file, right? So instead of people just going from Docker, build these things and run these things and copying the cache command, they can use the pre-built Docker binary that you release with all your helper scripts in them, and they can share them.
So I see you have a version there in the URL.
Yeah.
So how do you cope with that? If you update the Docker YAML, do you also increase the version?
So like technically that's a branch, so it will update. But you could use explicit tags or not, or it's kind of like I would kind of use somewhere between a semi-immutable version. So if you use semver, you can make changes. As long as they don't make breaking changes, it's okay. And considering it's an internal release process, even if they are semi-breaking changes, it's probably not the end of the world. But I mean, it's a choice with how paranoid you want to be. Do you want to get automatic updates, or do you want to explicitly change it every time there's a minor increase or optimization? I mean, I guess it's a choice of what teams or how you want to roll this out internally.
I mean, there's always the trade-off between delivering the latest features,
Yes.
keeping the development
Yeah.
moving.
Yeah.
If you do a release, then you don't want to have this latest stuff. You want to have, like, even the pipeline, you want to have version. So
Yeah.
you need to, I mean, I know it's difficult to have, like, how do I get the current version of the latest stuff I'm using if I want to make a release, because I want to version all my stuff, the tests, the pipeline.
So the way GitLab works is that once you do a git push, the pipeline state becomes immutable, and no matter how many times you rerun that, it will still run off the version that was created before.
This is in your pipeline, right? This is
Yes.
Like, this is interpreted.
Yes, but it's interpreted at push time, not runtime, right?
Are you sure?
Yes,
Okay.
I'm very sure. But like the include syntax runs at like push time. So when you do a git push to GitLab or whatever, it goes and it generates a pipeline that needs to run, and then it runs that. So no matter how many times you click the rerun button or retry, it will kind of use the version that was generated, because I tried to rerun it to get an update and it didn't work. But whenever you make a new git commit or push another commit to it, it will re-pull down the latest changes.
But then you still have this problem. If you make
Yes.
a security fix or a fix or
Sure. But again, then you need to have a versioning standard in your company and decide to use it the way you want to use it. It's the trade-off between, do you explicitly pin versions to the minor patch releases, or do you allow some flexibility and automatically get security updates? It depends on your company and your organization. And I'm not proposing one or the other. I think that they're both valid depending on how you do them. So back to the...
Question, can we go back to your pipeline? Didn't you say in the go forward? So the thing is that you said before that in your product, so in the application you're releasing, you're actually also testing the CI process. Or is that the CI stuff you're actually including? Or is that a different pipeline?
There are two separate pipelines. Sorry if this is not confusing. We have time for questions, so I can actually show you the Git repos afterwards if you want. I think it might be a little bit clearer there. So back to this whole topic of we're like kind of unable to learn from ourselves. I think we need to, the whole takeaway from this whole talk is that I think we need to get better at sharing pipelines between teams. That's basically it. This is one attempt to do that, but I honestly believe that teams should not be rebuilding ways to release code. That should be done in a semi-centralized way, in an opt-in way, where people can kind of choose to use the best practice release process or the best practice NPM version release stuff. Sure.
So, but then why don't you build like central build server for them and do for them? Why you force them to use your pipeline at all?
Are you a developer or do you run CI systems?
Both.
Okay, so if somebody gave you a build server that had a specific version of Node on it or a specific version of Docker, and you wanted to update that, and like, I'm answering your question. So if you were given these explicit versions of lockdown things and you wanted to make a change to that, and you had to log a ticket to get those like increased or things like that, then it kind of becomes this bureaucratic ticket thing where you backwards and forwards, where you centralize stuff. The whole idea behind GitLab's build runners inside Docker and Jenkins's like automatic slaves is that everyone gets a clean build system that is isolated and unique to their project, right? The problem with that is that you still need to have shared dependencies that can be kind of like linked somewhere, if that makes sense. Like back in the day when we were all building like a single Jenkins server, and the way that we would build our Java apps is we would install a whole bunch of plugins on the Jenkins server, and we would install multiple Maven versions, and then we would configure our Jenkins job to use Maven version like 20, and it became a nightmare to maintain because now you have like 30 versions of Maven, and now you want to add Python builds to the Docker. Like it becomes a dependency nightmare. So the world has kind of gone into a distributed computing where we run everything in containers and everything is isolated and everything is there. And developers want to build in whatever tools and frameworks that they're kind of allowed to. But our CI process is not up to standard where we can deal with that freedom, but still require people to not waste time figuring out everything all the time. Sure, I'm happy to talk. So the idea here is that we should be standing on the shoulders of giants and be able to leverage our internal tooling teams or our internal teams that necessarily can help us, but not necessarily in a bureaucratic forced way. It should be an optional, this is actually better to use than writing thousands of lines of YAML ourselves and maintaining it. And that's basically it. So before I get to questions, I know I'm like 2 minutes over, so sorry. If you go to druben.github.io/presentations, there's a list of this presentation and there's links to all of this in the slides. But the thing here, sorry, it's not mirrored. Wait, hold on. Sorry. Bear with me. Mirror displays. Okay, so both of these projects are kind of open source, and the idea is that you can use them for your own. But the first is the CI base repository, which includes all the helper scripts and the Docker image and the GitLab CI file. And although my example was a little bit like simplified, this includes a whole bunch of other magic as well. So building stuff on GitLab in Docker is not as simple as just Docker build. You need to inject service information. You need to update the Docker driver to overlay to. You need to do a whole bunch of hidden things, right? Then you also need to like pick where you want to do it and how you want to do it, and all of those processes. And the same goes for releasing like a workflow. So for example, like bin master. So like you need to log in, you need to build, you need to push it to a registry, you need to like tag that with the commit hash and latest, and then like push that all and like things like that. But if you compare that to this like simple node example that just basically contains I don't know, 8 lines of YAML, you still get the whole release pipeline out of the box with all of those built-in magic and Docker best practices and build caching and all of those, but without having to explicitly have everyone define them.
So actually with this file, that your, let's say your development team have to put in the project.
Yes.
But so it's very few lines.
Yes.
But can you remove them?
Sure.
I mean, just provide them some generic way. I mean, maybe the setup, test, and release quite common.
Sorry?
I mean, the stages like setup, test, and release might be quite common. Why don't you remove even them?
Because the idea here is to give people flexibility and allow them to opt in and choose what they want to do, right? So this is kind of a super simplified example of it. But for example, if they don't want this project to have release stages yet, they can just ignore it. And then they will still get the Docker build, but they won't necessarily have the deploy to production, for example, right? So the idea here is that you build modular components that are reusable, right? And you can reuse them as you choose, okay? But the explicit point is that the team needs to make the choice of how they want to use it. Because if they're forced to use it, then there's no difference to going back to a central server that is managed by a sysadmin from the 90s that they can't control or can't log into, right? I mean, this is the whole tension between too much flexibility and not enough flexibility. This is kind of the best compromise that I found. As a side note, you can do all of these things in other languages or frameworks too. Circle CI released 2 weeks ago something called orbs, which are basically this as a package service. So Circle CI has orbs for Heroku and Kubernetes and a whole bunch of other things that allow you to abstract your CI process, and instead of writing hundreds of lines of CI code, to just Kubernetes deploy with a bunch of parameters. And then you can reuse that. Cool. Any other questions? Sure.
Thank you very much. What I really like was the choice that you emphasized on the choice, and that's great. And now I wonder how you can test that, right? So
Test what part of this?
yeah, what are the underlying the inner guts of this?
The inner guts of this?
Yes.
That's this, right?
Yeah.
So you can look through the repository. It's actually quite convoluted. But this CI base is tested in the sense that it runs a bunch of like unit tests on itself. So here you have automatic shell check linting, so static analysis on CI, which is quite cool. Then you have unit tests on each of the build scripts, right? So Docker login, Docker push, and a whole bunch of other tools. So for example, in order for this CI job to pass, the Docker push job, it needs to be able to build and push the Docker image to a remote registry, but it also needs to be able to pull it. And if it can't pull it, then the test will fail and it won't work. And then you also asked about the release process. So because it uses itself to release itself, right? If it is able to release itself as a Docker version with a tag version number, it means that your developers will be able to release themselves. It's kind of meta programming with Bash and GitLab.
I like that because it's what you did. But my question was more like, how do you make sure that you catch with your tests the expected user experience, or what the way your users will use your offering? What is your approach to that?
So the approach to that is, I mean, obviously this is a contrived example I built on Sunday, but I did use something almost exactly similar with a team of 20 engineers with, I think, 50 or so microservices. The way you do it is you actually just verify how people are using it and what they're doing. And 90% of the time, like 99 or 95% of the time, developers don't care. Developers want to build features and they want to release their code. The 5% that do care should be allowed to do what they want to because they're smart enough and are able to do it. But the other people, they just want to be told, if I copy these 5 lines and I have a NPM project or a Go project, it will work. That's basically it. If you tell people, if you have these like conditions, it will work exactly as expected. And if you don't, try it and we can help you and make it work, that will work. So this example is just kind of an NPM package with a Docker build process, but previously our company standardized on NPM and Docker and deploying to Kubernetes. So I abstracted a whole bunch of Kubernetes logic away as well in that process with this like type of setup where developers didn't need to do any of the magic. They just needed to push to test to get it deployed to the testing cluster, or push to production, and then the code would land up on production with the correct like validation steps and the correct like rolling out the correct Docker image to the correct manifests in a kind of slightly abstracted way. But I mean, the use case will differ depending on your organization and your tooling, but the idea is provide people the tools and the workflows and the frameworks and allow them to adopt what they choose. And if they don't, that's fine, but then the training wheels are off and then they have to go and read the hundreds of lines of YAML definitions or learn Groovy or something like that.
I can actually confirm what you're saying. We did something similar in my last company, and it was exactly as you said. We gave them the toolbox, they used it, and if they wanted to change something, they could do it in their own repositories. And as you said, the training wheels are off there. It's their choice to change something. If they said it's sensible to contribute back because it has something, it might have something to do everybody likes, then it's okay. But if not, then it's also okay.
But I think the other difference here is it's not an all or nothing approach. Yeah. And that's why I try to highlight the difference between Docker and Node. It should be like language/type specific. So you should build workflows for specific types of things. Is this a stateful service? Then you can use this type of magic. Is it a stateless Go service? Then use this magic. If it's a NPM service, use this. But I think that we're far too often rebuilding the same workflows for the same types of apps that just have slightly different code underneath. We've solved the abstraction problem. Deploying applications is now just as simple as giving a Docker image and running it and having the ports mapping. We don't necessarily need to care about libraries or versions, but the release process is still not as clearly defined as it could be. And I mean, this is the one thing that I actually like standards and corporate bureaucracy, because in some regards they help, because there's always a set way. The problem there is that they enforce the set way across a whole bunch of different tools that don't necessarily follow those set way. But if you have like the best golden path for specific types of tooling, and people can choose to use X or Y, or people can contribute, I don't know, Y to X or something like that, then I think you encourage this idea of learning and sharing, and then you will eventually get a better system. So, I don't know.